Okay, so the recording has started. So we did go through the list module section. So today we are going to go through loops and recursions in OCaml. The corresponding OCaml.org's page is /loops-recursion. Let me share that in the chat, so you can also take a loop at it. I've also updated the notes with the relevant sections that we want to cover here. So with that, let's get started for today's session. So this is an example for a for loop. So the general syntax is for variable is equal to start value to end value. You do evaluate some expression, and yeah, a simple real world example looks something like this. For I is equal to 1 to some number of jobs, you do the next job, right? So in OCaml, for loops are just shorthand for writing something like let I is equal to 1 in do this job, let I is equal to 2 in do the next job, and so on, right? Of course, here we don't support the concept of breaking out of a for loop. So there are like no break, continue, or last statements as you will have in other programming languages. You can of course throw an exception and catch it. Okay. The important thing here is the for loop should evaluate to unit, and it must return unit. Okay. So let's see this here in the OCaml.org playground. So I will share this link as well. Right, you can use it to actually try the actual commands. Let me clear the output. So here if I do something like for I is equal to 1 to 10, do I done. Now here I am outputting an integer, right? So it gives you a warning saying the expression should have type unit. So the for should actually evaluate and return unit. Similarly, you have a while loop construct. So while a Boolean condition is true, you execute the expression. Again, as with for loops, you cannot break out of a while loop in OCaml, and while loops are second class citizens. Right? Although we can use while loops with references. So let's see this example here. So we have a quit loop is equal to false, and then while not quit, so while not of false is true, then you print the string have you had enough yet, and then we read a line from the input and assign it to string. If the first character of the string is yes, then you proceed further, right? Now I can't try this on the playground here because we don't have input or read line will not work on this, but later on when we actually set up op-amp switches and OCaml on your system, you can actually try this example. Okay. So in this case, the quit loop is actually not a real variable. The binding just makes the quit loop to false so that you can run through the while expression, and this while will of course run forever. OCaml does have references, so you can specify let quit loop is equal to ref of false, and while not of, you're actually taking the value of quit loop here. Okay, you're printing the string, getting the read line input, and then you're checking the first character to be yes, and then you can set quit loop to true, and then this will exit. Okay. Hi, Real Chakravarti, how are you doing? Thanks for joining in. Feel free to ask questions in the chat. I will of course make the video also available later on the YouTube channel. So we are going through the loops and recursions in OCaml. So we briefly looked at the for and the while construct, but given that OCaml is a functional programming language, the preference is always to use recursion. So we will look at those examples in this section. All right. So this is an example of looping over list, right? So we have seen a lot of functions in the list module. So it's now useful for us to look at these examples. So let's define a list first. Let's clear the output, and I'm going to define a mylist which has 10 integers, so it is a integer list. Okay. Right. Now if I want to call a function on every element of this list, so you can use the list iter function given here. Real Chakravarti is asking what OCaml is used for anywhere. There's a quite a number of industry folks who actually use OCaml. So if you go to ocaml.org, and this is a home page. I'll share the link in the chat. So I know that Meta, Facebook uses it. Jane Street Capital has been one of the big supporters and funders for OCaml. Bloomberg uses it. Tezos Foundation here, Ahrefs. So a lot of companies actually use OCaml in production. And if you click on this link on success stories, you should be able to find more case study reports on who's using it in the web domain, in finance, trading systems, in IoT, social networks, and so on. So quite a number of industry players are actively using OCaml. Okay, let's continue. So we have this list, and we are now exploring iterating over the list and calling a function on every element on the list. So we define f_lm is equal to printf I am looking at element %d now, and just called lm in. I'm calling list.iter, applying the function to this list. Okay. So for every element in my list, I apply this function. What is this function? This printf. Let's clear the output. Let's run it, and you look at the output as I'm looking at element 1, 2, 3, and so on. Okay. Right. Let's move on. Now if you want to transform each element separately in the list, for example doubling the list, can also do list.map. So let's, for example, do list.map, right? I'm going to multiply each element by 2 and I get 2, 4, 6, 8, 10 and so on. Now we also have the list.filter function, which basically collects only those elements of a list which satisfy some condition. So let's say we only want to return the even numbers in a list. Okay. So I can define let is even of I, and if it is divisible by 0 in list.filter is even of the input list, right? So what this will do is only for those elements in my list which is divisible by 2, it will basically return the elements. So I get 2, 4, 6, 8. Okay. You can also do list.mem to check if a element is a member of a list. So we can do, say, list.member of 12 of my list. Is that a member? No, hence it returns false. Similarly, we have seen the list for all and list exists operators in predicate logic, and the corresponding functions have been implemented in list as well. Now, to operate on two lists, of course, you can use the iter2, map2, for all exist2 functions, and we have seen some examples of those. The map and filter functions, of course, operate on individual list elements in isolation, and if we want to have a sort of an accumulator which can hold or result values while we compute the function for the rest of the elements of the list, we can use the fold function. You've seen those. Real Chakravarti asked, can't we write in the same line after in? This is enforced by the language itself. It's just clear and concise for reading. You will see one-line functions as well, so that's possible. It's just it's easy to read, and white space is good for legibility, right? Good question. So we have seen the list fold left and fold right. I've explained that in detail in the previous session. So the videos are available on the channel, and if you go to the Emacs and OCaml and FOSS playlist, the OCaml playlist, you will have the previous recordings available. So in the list module 1 and part 1 and part 2, I have covered some of those functions in detail. Okay. All right. So let's again quickly check the list.fold left. So we define sum as list.fold left. We do the plus and initial accumulator value is 0, so that's just sum. So that's the sum definition. I can also define let product is list.fold left 1, so that should be good. So the important point here is sum of an empty list should be 0, it should not throw an error, and similarly product of an empty list should return 1. Right? So to handle those cases, we have these useful functions. Now, of course, to handle the left and right associative operations based on parenthesis, there are the left and right fold operations. So, in this example, we are just using the fold left function. So, now I can just call sum on my list, which should basically return 55, so the sum of all the elements in the list, and similarly product of my list should return the product of all the elements in the list. Okay. Okay. So now we can use these functions and build on top of these functions. So we can write a simple factorial function, fact of n, using our product function. We call range of 1n. I may not have defined range. Yeah, so let's define range. We use it in the one of the previous sessions. So we define a recursive function range as AB. If A is greater than B, then we return the empty list. Else, we create a new list with A, and we call again range as a recursive function with A plus 1 and the rest of the list. Let's clear this and make sure it compiles. That looks fine. And now if we actually call factorial of 10, for example, this should return the result. Good. Right. So this is how, like, we have definitions, and then you have like simple helper functions, and then you build on top of those functions, you write actual programs. That's sort of the functional style of writing. The string module also contains a lot of useful string related functions, string.copy, string.iter, and so on, and they are mostly similar to the list.iter operations, except that we are now operating in strings. Okay, so as I said, for loops and while loops are like second class citizens. The main important aspect of using functional programming style is recursion. And if you're like new to writing recursive functions, it will take some time to get used to it, but we'll walk you through the steps, and once you start writing small programs, you will better understand how to build on top of them. Okay. So here's an example of reading a file into memory. So it is a long string, right? So what are the different ways by which you can actually read a big file into memory? So this section talks about 3 approaches. Now, if you know the length of the file, you can read it all at once. There's a really input method which is pretty simple, but it may not work in all cases. Let's say you're reading from a network or reading from a socket, right? So there could be blocking and so on. So you may not know the length of the file in the first place. So it may not work in all cases. So that is one approach. The second approach is again using a while loop, but then it will not have a break, condition. You can throw an exception, but that's not the ideal way, right? So the approach 3 is using a recursive loop to break out of the recursion. Okay, we can use an exception here. So there are some examples that are written to demonstrate this. Okay. So let's go through each of the code examples here. In the first case, we said we will read the whole file. Okay. So there are 3 definitions here. We open the printf module to print. So let's start from the main function. We have file name is this argv1, we're passing an argument, and we're calling this our own read whole file of function with the file name as an argument, and then we're just printing the characters from the file name. What does this read whole file do? The read whole file function takes the file name, it uses open in call to open the file name, which in turn calls this read entire file, the read whole channel, and passes the channel to it. What this read whole channel function here does is it determines the length, it uses an argument chan to this in channel length, and then it gets the result by using bytes module, calls this really input method, passing the channel, the result 0 and the length, and gets the result and returns it to the main function. Okay. Now, as I said, this may not work on non-file channels like keyboard input or sockets. Right. Now, in this OCaml.org play, I cannot actually use any read. There's no read input, but later on when we do the actual implementation in maybe in utop or console, we should be able to try this out. Real Chakravarti is asking, we aren't closing the file after reading it. Let me check if there is a function that actually does that. Just hold on to your question. Okay. Let me just finish this approaches. I'll come to it. Now the second approach here is using a while loop. The same thing, right? From the main function, we are passing an argument. We're calling the read whole file name. We are printing the characters. And what does the read whole file method do? Same thing, open a channel, the file name. And earlier we had used the bytes module to read the entire file because we know the length, but now we are using a while loop, right? While true, you do line by line, and here you are initially you're creating a buffer of some size, reading line by line, adding the line to the buffer, appending with the new line. Once you're done, and you exit. Okay. And when you reach end of file, just return the buffer contents and we print it out. Again, we've seen while and the full reading the full file. Now the preferred approach here, right, is given here, right. So we're using a recursive function here. Let me walk you through this again, right. So again we pass the file name, use the same read whole file function, and we open a channel, although it is the same. So in the read whole channel definition, again we create a buffer, and here in recursive loop, we're again reading each line, adding the string, appending the new line, and again calling loop. Do this in a try exception kind of block. So at each end of file, we just return the contents back, right. So this is the recursive implementation. Now of course the infinite recursion is broken when the input line throws an end of file exception. Okay. Now we can actually type all of these in the OCaml.org play environment, make sure our type definitions are actually correct, but we will not be able to execute it because we won't be able to like pass an argument to it. So that's the three approaches. So what is the takeaway of these three things? So the key point is, as much as possible in functional programming, we want to use recursion, and this is the type of style that you will see in a lot of OCaml code. You do the let recursive function in, you actually execute the function. Real Chakra is asking, so exit condition is throwing exception inside. Yeah, that's correct, in try catch. So we are calling this with these definitions. Yeah, that is correct. Does that make sense? Okay, that's good. Okay, let's stop here. I'll just stop the recording here so that I can later on upload it to YouTube, and then we can take in more questions.